In this video, we're going to continue on with implicit differentiation. This will be implicit differentiation part 3. So we're going to do a couple of more examples. And so in particular, example 2, we're going to find y prime when y squared is equal to x squared plus sine of x y. So using implicit differentiation, we take the derivative with respect to x of both sides. Okay, and now let's go ahead and derive the left side. We apply the chain rule here, so this is 2y dy dx, or I'll just write y prime, since it's understood that our independent variable is x here. And then we'll take the derivative of the right side here. So we can take the derivative of each of these two terms separately. The derivative of x squared with respect to x is just 2x. The derivative of sine of xy with respect to x, though, is, all right, well, the derivative of sine is cosine, so this is cosine of xy, times, and now we need to multiply by the derivative of the inside, because that's what our chain rule says. And so the derivative of the inside here, the derivative of x times y, is a product rule. Okay, so what does our product rule say? We take the first, x, times the derivative of the second, which is y prime, plus the derivative of the first, which is 1, times y. All right. And then we want to solve for y prime. How do we do that? We collect all of the terms with y prime on one side. So this is 2y y prime is equal to 2x. And then we have plus x y prime cosine of xy, plus y cosine of xy. And then we move everything with a y prime in it to one side. So this is a minus xy prime cosine of xy is equal to 2x plus y cosine of xy. Factor out a y prime. Oops, sorry. So all we did here was we moved everything over again with the y prime in it, and everything without a y prime we put over to the right, factored out a y prime here. This is equal to 2x plus y cosine of xy, and then we can divide by all of this to solve for y. So we get y is equal to 2x plus y cosine of xy divided by 2y minus x cosine of xy. And that is our solution. Sorry, that's y prime. And that is our solution in terms, y prime is in terms of both x and y here. That doesn't always happen, but honestly it does happen most of the time, that we will have a y in our function over here. And that's okay. Generally that will happen. Okay. So we have another example that we want to do now, and that is example 3. And we are going to find the second derivative with respect to x when 2x cubed minus 3y squared is equal to 8. So let's go ahead and solve that now. And to do that, we need to find the first derivative. So our first derivative, we take the derivative with respect to x of 2x cubed minus 3y squared is equal to 8, is equal to the first derivative with respect to x of 8, right? We derive both sides with respect to x. So our left side is 6x squared minus 6y y prime is equal to 0. And so we get y prime is equal to negative 6x squared over negative 6y. So this is x squared over y. And that's our first derivative, is y prime is equal to x squared over y. All right. Now let's take the second derivative. And so we take the derivative with respect to x of y prime is equal to the derivative with respect to x of x squared over y. The left-hand side here is y double prime. That's just the second derivative. And the right-hand side requires us to use the quotient rule. So that is the denominator y times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Which is, we can separate this fraction. Y over y squared reduces to just a 2x over y here, minus x squared y prime over y squared. Now here's our thing. We're okay with having a y here, and sometimes we're okay with having a y prime here in our solution for y double prime, but we know what y prime is in terms of x and y, so if we can now replace, and in this case we can. Minus x squared times x squared over y all over y squared. So this is 2x over y minus x to the fourth over y cubed. And that is our second derivative with respect to y. Second derivative of y with respect to x. And that is where we will end this last video on implicit differentiation.